Good morning to each and everyone. Good afternoon, good evening, and good day. I am Paul and I will now be discussing the second type for testing the hypothesis. The second type is the significant testing or the p-value approach. Before we proceed to the actual steps, we must understand what is the p-value approach. By definition, the p-value approach in hypothesis testing determines the evidence against the null hypothesis by calculating a p-value. In this p-value approach, we will be using a p-value, of course. By proving the evidence against the null hypothesis, we must first calculate the p-value. But before we come up to the actual p-value, there are other steps or other formulas that we have to consider to get to the p-value. How it works? It measures how surprising your data is if the null hypothesis were actually correct. The smaller the p-value, the stronger the evidence is against the null hypothesis. Uh, by the word itself, we must remember this sentence, the second sentence. The smaller the p-value, the stronger the evidence is against the null hypothesis. Next is we must first know the decision rule or the conditions for computing the p-value or for concluding if we reject or we accept the null hypothesis. The first condition is if we reject the null hypothesis. This is statistically significant. If the p-value is less than or equal to the alpha level, let's say for example, we have a value of p which is 0.04. Obviously that is less than 0.05. In that case, we reject the null hypothesis. Or let's say for example, the p-value is 0.05 as well. It means that 0.05 of the p-value is equal to the alpha level of 0.05. This 0.05 is the standard value of the alpha level. It may vary depending on the problem and the given. This alpha level may change depending on the given problem. Yun ay makikita nyo rin later on sa ating mga sample problems na hindi laging 0.05 ang ginagamit. May times din naman na hindi given ang alpha level. In those cases, we will use 0.05. In this rejecting the null hypothesis, the observed result is unlikely to occur by random chance if the null hypothesis were true. And you reject the null hypothesis in favor of the alternative hypothesis. If we reject the null hypothesis, of course, the alternative hypothesis will be the true statement in the problem. What is the second rule or the second condition? If we fail to reject the null hypothesis, basically we accept the null hypothesis. This is not statistically significant. If the p-value is greater than the alpha level, let's say for example, we got the value of p here of 0.06. Obviously that is greater than 0.05. In that case, we accept the null hypothesis. Same thing, we fail to reject the null hypothesis. The observed result is likely to occur even if the null hypothesis were true. Ibig sabihin, mataas yung chance or most likely mangyayari yung nasa null hypothesis, which is proven when we solve for the p-value. What is the conclusion? You fail to reject the null hypothesis. It means that you do not have enough evidence to support the alternative hypothesis. I hope you understand the decision rule The the first is to reject, and the second one is to accept the null hypothesis. Now, we will be proceeding to the main topic or the main agenda of my discussion, which is the steps on testing the hypothesis using the significant testing or the p-value approach. So for the first step, we must state the null and alternative hypothesis. So before we proceed to computing the z value, the critical values, the p-value, and before we conclude, we must state first the null and alternative hypothesis. We must know first kung saan tayo magbe-base ng ating conclusion. So that is the first step. So for the second step, we determine the appropriate statistical test based on the level of measurement of the data gathered. So in this step, we consider two things, or we use two statistical tests that is based on the level of measurement. Let's say for example, there are two tests that we are using. So the t-test and the z-test. So it may vary depending on the problem again. So when we are using z-test, the value of n is greater than or equal to 30. So what does it mean? So let's say for example, we got a sample of 35. So obviously that is greater than 30. And there are some cases that we also based on the sample population, sample standard deviation. So let's say for example, if the variance is unknown, and what I said earlier na we have n that is greater than 30, we use the z-test. So make sure to remember that when we use the z-test, we have a greater than n, we have a value of n greater than 30, and the variance is unknown. So next one is the t-test. So the opposite one of the z-test. So we have a value of n that is less than 30, let's say for example 25, and the variance is given to the problem. We use the z-test. So you will see later when we use these steps. So for our step 3, compute the test statistic. So from the given formulas, so we will compute for the test statistic. So sa mga susunod naman ng topic ay madi-discuss din ito, but I will provide some examples so that hindi na kayo mag-struggle sa pagsosolve kapag na proceed na kayo sa next topics na i-discuss ng aking mga ka-group. So for the step 4, compute for the p-value based on the computed value of the test statistic. So here, before we come up for the computing of the p-value, we must first determine the z-value or the t-value, and as well as the critical values, so that we can locate in the z-table or the t-table. So later on, I will also teach you how to locate the critical values in the z-table. So that one is also an additional learning for my discussion, so that you can proceed smoothly on the next topics. So what is step 5? So here in step 5, we state the decision based on the resulting p-value and the knowledge of the scientific system. So here in step 5, Yung diniscuss ko kanina na decision rule, dito tayo magbe-base ng isasagot natin. So, from what I have discussed earlier, it's either we reject the null hypothesis or we accept the null hypothesis. So, here in step 5, dun tayo nagde-decide kung i-reject ba natin or i-accept ang null hypothesis based sa conditions at sa result na p-value. So, after we decide, we will now conclude or we will draw in scientific or engineering conclusions for the given problem. So, here in step 6, this will be our final answer in the problem. Yun. So, now I have completed the steps in hypothesis testing using significant testing or the p-value approach. Let us now solve for a sample problem. So, I have 3 sample problems here that you may, I hope, maintindihan nyo rin. And, doon sa 3 sample problems ay magagamit natin at i-indicate ko rin kung anong step ang ginamit. So, let us now proceed for our sample problem number 1. So, for our next problem, for our first problem for our problem 1, the average score of the students in the recent midterm examination is 45. The professor believes that the true mean is to be different. He computed the grade of 100 students and found the mean to be 50.5 with a standard deviation of 20.5. So first, state the null hypothesis and alternative hypothesis. And B, at a 95% confidence level, is there enough evidence to disregard the null hypothesis? So, paano ba natin ito isa-solve? Based sa steps na tinuro ko kanina. So, let me read the problem once again. The average score of the student in the recent midterm examination is 45. So, first we have to list down the given in the problem. So, we have mu. Wait. So, we have here our mu is equal to 45. So, next is the professor believed that the true mean is to be different. So, sabi dito, yung true mean daw ay not equal to 45. So, we have here our null and alternative hypothesis. So, we will list down this one as our null hypothesis and this one as our alternative hypothesis. Next, so the professor daw, he computed the grade of 100 students. So we have our n, 100, and found the mean to be 50.5. So our mean daw is 50.5. So in short, our x bar is 50.5 and with a standard deviation of 20.5. So first is we state the null hypothesis and alternative hypothesis. So we now have our null and alternative hypothesis, which is this is our letter A. So we have our here check, and B with a confidence level of 95%. So sabi, ang confidence level daw ay 95% or 0.95. Ang tanong, is there enough evidence to disregard the null hypothesis? So meron ba daw enough evidence para ma-disprove or ma-disregard ang null hypothesis? So, in this problem, we have our confidence level. So, what we don't have is our alpha level. So, to compute this one, this alpha, we use 1 minus the confidence level. So, we have 0.95 here. So, 1 minus 0.95. This is how you compute the alpha level. So, we have 0.05. This is our alpha level. This 0.05. So, the next step that we will do, based on what I discussed a while ago, so the second step is to to determine the test statistic that we will use. So, sabi, kapag daw ang n, pag daw ang n is greater than or equal 30, we will use z-test. At kapag ang n naman ay less than 30, we will use the t-test. Since we have our n, which is 200, so we will use the z-test. Now that we identify the test that we will use, the next thing that we have to do is to compute. So, like I said, we will now computing the test statistic. So, I will not be providing the test statistic, but it will be discussed by other group members. And sorry if I will spoil this one. So, we have a formula of the calculated Z statistic, which is equal to the mean of the given problem and the average score, or the null average score, which is, this is 145, this is null, over the standard deviation, and then divided by the square root of n. This is our formula to get the calculated z-score. Now that we have identified the formula, let us substitute the given problem. So we have a mean of 45. We have a mean of 50.5 minus to the given average score of the null, which is the 45, over we have a standard dev of 20.5 over square root of our n, which is 100. You can substitute this to the our calculator, but for now we will compute it manually. So we have 50.5 minus 45, this is 5.5, over so 20.5 over square root of 100, which is 10. So next is we compute this denominator. For a while, I will just use my calculator. So 20.5 over 10, that is 2.05. So we have 5.5 over 2.05. If you compute this value, this is 20.5 over 2.05. 5.5 rather. 5.5 over 2.05. We get a value of 2.6829. So this is our computed Z score. So this is our this is our computed Z score. Ayan. So after we get our compute.z, we will now first we have to draw the curve. Sorry, let me fix it for you. My apologies for my ugly drawing. So we have here our null and alternative. Let me change the color. So we have here a two-tailed test. So in this problem, we will be using two-tailed test. So in this region, we have here, inside this region, we have here our 2.68. So this is negative 2.68. And we have here our 2.68. After we locate this one, so now we have our value here, which is the 2.68. So we have to identify first the so since we have our value here, which is 2.68, we want to compute the areas here to the left. Since this is our 2.68, we want this area to be computed. We want this to locate. So to locate that area, so we have our z that is corresponding to the accumulative area to the left. So how do we locate that? What I've said earlier, we will use the z table. Since we have a value of 2.68, so we will be locating 2.6, so this is positive 2.6, and we have here the 0.08. So under this area, and we will go down until we reach the cross section of the 2.6 and 0.08, which we have a value of 0.99632. So remember this value. We have a z of 2.68 corresponding to our value, which is a 0.99632. Now that we have our accumulative area, so since we have here our value, which is the 0.99632, and what we want is the value of this one, and to compute that, we will subtract this accumulative area to the left to 1. So to get that, so 1 minus 0.99632. Wait, I will just use my calculator. 1 minus 0.99632 is 0.00368. So now that we have our value, this one is 0.00368. Now that we have our value 0.00368, so this one is the same here, which is 0.00368 as well. So you might be confused, bakit wala tayong sinolve dito. So this is irrelevant, but if you want to know the value of this, is we will subtract the area, which is the 0.99632. Sorry, this is 6 minus the value that we get, which is 0.00368. So that will be 0.99632. So the value of this unshaded region is 99632 minus 0.00368. So this is equal to 0.99264. So this is the value of the unshaded region. While the shaded region, the value of its is 0.00368. So now that we have our value here, this is essential to get the p-value. So how do we get the p-value? So we add the computed of the shaded region, the value of the shaded region, which is, so we have 0.00368. So p-value is equal to 0.00368. Since ito naman, ang left side at right side ay same lang na 0.00368, we will just multiply it by 2. So to calculate 0.00368 times 2, which is 0.00736. This is our p-value now. So now that we have our p-value, going back to our next step, which is we will now be stating the decision based on the resulting p-value and knowledge of the scientific system. So gaya ng diniscuss ko kanina sa decision rule, if the p-value is, wait, we will bring back to the PowerPoint, to the decision rule. So if the p-value is less than or equal to alpha, we will reject the null hypothesis. And if the p-value is greater than the alpha level, we will be accepting the null hypothesis. So we have here, since the p-value is 0.00736, obviously this is this is less than 0.05, since we have a lesser value. So what do we mean by that? We will now reject the null hypothesis. So what does it mean if we reject the null hypothesis? Going back to our given null and alternative hypothesis, so this is proven wrong. The average scores of the student is 45. So what does it mean? So it means that our it was proven that the 50.5 scores, the average scores, is true, since we have our alternative hypothesis here, which is 45. How do we conclude that? So going back to the question of letter V, so at a 95% confidence level, is there enough evidence to disregard the null hypothesis? Since we have our answer and we got the p-value of this, we have proven that the p-value is less than 0.05, which is the alpha level. So it means that at a 95% confidence level, there is enough evidence to disregard the null hypothesis. This is what we computed. This is the proof that we have enough evidence to disregard the null hypothesis. So what does it mean? Let's just type it. So means that let me just change the font size. I think it's too small. Yan. Going back, so it means that the sample mean X bar 50.5. This is our sample mean. This is significant, since from our decision rule, If we reject the null hypothesis, it is statistically significant. So it means this is statistically significant. Now, we conclude that the true average score of the students is significantly different from 45. So, from our null hypothesis, we now conclude that the average score of 45 is significantly different. And this is now our final answer. Now that we have our first step, step by step on how we solve the the significant testing or the p-value method. So to summarize, for our first problem, first we locate the null and alternative hypothesis. After we locate the null hypothesis, so the null and alternative, so this is the first step. Let me just let me make it red for you. So this is our first step. Our second step, we determine the test that we will use. The test is statistic. So based on the condition where n is greater than 30, which is our n is 100, we use a z-test. So this is our second step. After the second step, after we determine the appropriate statistical test, now we have z-test, we now compute for the test statistic. So by providing the given formula and by computing it, this is our third step. Now that we have our z value or the critical value, this is what we call the critical value, this one. After we computed for the critical value, we will now be using the z-score. Since we have a value of 2.68, so 2.6 and 0.08, and that cross-section or the value where they meet, which we have 0.99632, and that is our part, that is part of our step 3, this one. So this is still part of the step 3. After we locate the value crossing on the 2.68, we will be using it to compute for the values of the shaded region. So we drew here our shaded region, which is, it is two-tailed test. We have here our 2.68, and we located for the cumulative area to the left, which is this one. This is still part of the test statistic, so this is the left part. This is included in this unshaded region. So after we locate for the cumulative area, we will now be subtracting it to 1, this area, to get the value of the shaded region. So now that we have computed here this one, we will now be computing the p-value. So this is our fourth step, wherein after we computed for the shaded area, we will now be multiplying it to 2 to get our p-value. So since it is the same lang, we have on left side, which is 0.008, 0.00368 as well as the right side. So originally we add this one, but we add the two values of the tail, left and right, but in this one we have same values naman, so multiply na lang natin. So yun, nakuha na natin yung value ng p-value. So for our fifth step, we will now be stating the decision. So going back to our decision rule, wherein we reject or we accept the null hypothesis. Since we got a value, the p-value, which is the 0.00736, and that is less than 0.05, so we reject our null hypothesis. So after we reject the null hypothesis, we will now be drawing conclusions based on the given problem. This is our step 6. So we stated earlier that the sample mean of 50.5 is statistically significant. Since this is our this is our alternative hypothesis, the value which is we have here. It was said earlier that the mean is not equal to 45, and we have a value we have the value of the sample mean, which is 50. 50.5. So this means that the alternative hypothesis is statistically significant. So we now conclude that the average score of 45, which is the null hypothesis, is significantly different. So by concluding this statement, we now answered the problem that I provided. So in this problem, we rejected the null hypothesis. So let us proceed to our second problem. So for our problem 2, Coca-Cola's standard claim is that their Coke bottles are filled with an average volume of 355 ml. Due to recent complaints, the quality control manager is concerned that the true mean fill volume is actually less than 355 ml. A sample of 40 bottles is randomly selected, and the average fill volume is found to be 353.8 ml with the sample standard deviation of 2.5 ml. So I have listed here our problem. I typed it. So now first we will be listing our given to our problem. So first thing we need to do is to identify the null and alternative hypothesis. So as stated in the problem, Coca-Cola's standard claim is that their soda bottles are filled with an average volume of 355 ml. So for our null hypothesis, our average volume is equal to 355 ml. Next is due to recent complaints, the quality control manager is concerned that the true mean fill volume is actually less than 355 ml. So it was stated that it was less than 355. So for our alternative hypothesis, our average is less than 355 ml. Next, our n is equal to 40 bottles, so a sample of 40 bottles. This end and the average fill volume, so this is our mean, is equal to 353.8 ml. Next, we have a standard deviation of 2.5 ml. Since the variance is unknown, how do we draw the variance? And since our variance is unknown, we have no variance here, and this is unknown, and we have Rn which is greater than 30, we will use the z-test. So, alam na natin ngayon na z-test yung gagamitin natin. So, based on what we listed, we have already achieved the first step and the second step. Next is the third step. We will now be computing the test statistic. So, based on our given, we will use the z-test. So, we will calculate the z-value, which is equal to the mean minus the average score and the null hypothesis over the standard deviation over the square root of n. Next, we will now be substituting the formulas, the given rather, to the formulas. So we have a mean of 353.8 ml minus we have a mean of 355 ml over, we have a standard deviation of 2.5 over square root of 40. So just type it to the calculator, and 353.8 353.8 minus 355 over 2.5 over square root of 40. So we have a value of negative 3.03. So this is our value. So we have calculated Z, and so based sa ating given the computed, so we will use the negative Z table, and based din sa ating null and alternative hypothesis, we will use left tail test. So ayan, and this is our shaded region. Then we have here our value. So going back, now that we have solved for our calculated Z, we will now locate for the Z crit. Since we have a value of negative 3.03, so here negative 3, this section, and 303, so 0.03. So we have 0.00122. So now we we got our value, which is 0.00122. Since this is a left tail test, wait, going back, let me move this one under here. Then this is our negative negative 3.03. Since ang kailangan lang naman natin ay itong value ng shaded region na ito, which is nakuha na natin, which is yung 0.00122. Now, this is our p-value. Since wala naman tayong kailangan i-add dito, and ito lang din naman yung kailangan natin, ito na yung ating p-value. P-value. So, now, tapos na tayo sa pag-compute ng p-value. Since nakuha na natin. Since wala naman tayong kailangang i-add or i-multiply, so, ito na yung p-value natin. Ngayon, i-compare natin siya sa alpha level. Since based sa problem, wala namang binigay na alpha level, I think we can just proceed to our standard alpha level, which is 0.05. So let's just state that our alpha level is 0.05. 0.05. So based sa ating alpha level at nakuhang p-value, we can say na itong 0.00122 is less than 0.05 na alpha level. So, anong ibig sabihin? Since si p-value is less than 0.05, we will still reject the null hypothesis. So, based sa ating null hypothesis, this 355 ml na average volume is proven wrong. So, ibig sabihin, to conclude, ang ating average fill volume na tunay ay 353.8 ml, which is the alternative hypothesis. So, based naman sa ating alternative hypothesis, the average fill volume is less than 355 ml, which is proven to be true. So, how will we conclude that? So, this is our step 5. Nag-draw na tayo ng decision based sa ating decision rule, which wherein we reject or we accept the null hypothesis. Now that we have concluded, we have decided if you will reject or accept, since based sa ating result ay nireject natin yung null hypothesis. So, what can we conclude from that? So, this means that yung evidence gathered from the sample 40 bottles, ayun, yung 40 bottles which had the mean fill volume of 353.8 ml. So, ayan, we have a sample 40 bottles and a mean of 353.8 ml is strong enough to conclude that the Coca-Cola bottling process is consistently underfilling the bottles compared to the standard claim na 355 ml. So, it means that this null hypothesis is proven to be wrong, which is proven by means of this p-value testing. So, now that we concluded uh, our final answer. So that is our step 6. So for our last problem, let me share my screen again on our Canva. So let us proceed to our third problem. Let me read it for you. A light bulb manufacturer claims that their new LED bulbs have an average lifespan of 15,000 hours. An independent consumer testing agency is skeptical and believes that the true average lifespan is actually less than 15 hours. They test a sample of 50 bulbs and find the average lifespan is 14,850 hours with a standard deviation of 600 hours. State the null and alternative hypothesis, and at 1% significance level, is there enough evidence to support the testing agency's belief that the manufacturer's claim is too high? So, let me put the problem here in my whiteboard. Wait a minute, no things. Stop show. So, wait, let me scale it up. So, it was said in the problem that meron daw lifespan yung LED bulb ng 15 hours. So, we can conclude that this 15 hours is our null hypothesis. So, first step, once again, wait, let me change my So for our first step, which is we will state the null and the alternative hypothesis. So for our null hypothesis, we have, it was stated in the problem that the LED bulbs have an average lifespan of 15,000 hours. So let's indicate here that we have the average mean is equal to 15,000 hours. So it was believed. So sabi sa problem, the independent consumer testing agency is skeptical and believes that the true average lifespan is actually is less than 15,000 hours. So sabi, mas mababa daw sa 15,000 hours yung assumption independent consumer testing agency. So medyo nagdududa si independent consumer testing agency. So sabi, it was less than 15,000 hours. My apologies for the symbol that I have used. So we have now our null hypothesis and our alternative hypothesis. Next, sabi sa problem, they test the sample of 50 bulbs. So our n here is 50, and they found out that the average lifespan is 14,850 hours. So our mean here is 14,850 hours with the standard deviation of 600 hours. So we have now our null and alternative. We have our n, the mean, and the standard deviation. So what is missing? So we have already stated the null and alternative hypothesis. So letter A is checked. So at a 1% significance level, so our significance level or the alpha value is at 1%. So let's just put here 1%. or clearly 0.01. So it was asked, is there enough evidence to support the testing agency's belief that the manufacturer claim is too high? So let's find out. So first, after we again and again and again, after we state the null and the alternative hypothesis, we now determine the appropriate statistical test. So like I said earlier, so we have our n. So our n is greater than 30, and the variance is unknown. So we will, but in this condition, we will use z-test. Since we have our n, which is greater than 30, and the variance is unknown. So we already determined the statistical test that we will use. Let us now compute for the test statistics. So this is step 2. So by our formula of the z-test, the formula is equal to the mean minus the actual mean over the standard deviation divided by the square root of our population. So let's substitute first. So we have our mean, which is 14,850 minus 15,000 coming from this given, over we have our standard deviation of 600. So this is 600 over square root of our n, which is the 50. So let us type this in our calculator. I hope you are solving too, so that you can follow me solving this problem. So 14,850 minus 15,000 over 600 divided by square root of 50. So our computed C value, we have a negative 1.78. So this is rounded off, since we only need two decimal places. Let me erase it. So by rounding this off, so I think you also noticed that the actual value that we computed is 1.767. So by rounding this off, since this is a higher number than 5, so this is negative 1.77. So this is our computed C value. Next, now that we already computed for our Z value, we will now locate our accumulative area. So by using the Z table, since this is negative, so we will needing negative C table. So let's just use what we have used earlier. Let me copy it, and then let's just erase this circles. So by locating negative 1.77, so we have here negative 1.7. Next is 0.07. So we come up with the value 0.3836. So our value ZC equal to AL, so we have negative 1.77 is equal to 0.3836. Next, we have now computed for our area values and the computed C value. So this is the Z crit, also called as the Z crit, critical value. Next, we will now be computing for the P value. So let us draw the graph first. So since this is wherein the mean is less than 15,000, so we will be using a left-tailed C test. So let me locate the values here. So let's just cut this in half, and we will shade this region. So this region, somewhere in here, we have a value of this is negative 1.77. So while ago we computed the Z is the critical value, which is 0.3836. Now, since we only care in this shaded region, we only need this one to get the P value. Since when we are getting the P value, we only get the sum of the shaded region. So now that we have our critical value, we can now compute for the P value. Since we only have one, since this is a left-tailed test, we only have one, which is 0.3836, and then this one, this is not included. So now this is our P value. We will now compare it to our alpha level. So our alpha level is equal to 0.01. So as you may notice, our P value is greater than 0.01. So what we conclude here is that since our P value is greater than the alpha level, we will reject the we fail to reject the null hypothesis. Reject null hypothesis. Why? Because based on what I have discussed in the decision rule, going back, let me proceed to next. So if the P value is less than if the P value is greater than the alpha level, we fail to reject the null hypothesis. So what does it mean? So we accept the alternative hypothesis. So since we have a P value that is greater than the alpha level, so we fail to reject the null hypothesis. So we accept the null hypothesis. So it means that we do not have enough evidence to support our alternative hypothesis. Which, what we got the value here, it was stated in the problem that the average lifespan is actually 15,000 hours. So we disproved that this statement is correct. And what do we mean by that? Since we got a value, we got a P value which is greater than our alpha level at 0.01, we accept our null hypothesis. So we accept that the average lifespan of an LED bulbs is 15,000 hours. So we in these steps we got the P value Since this is step 4, we have computed for our p-value, and this is our step 5. Since we failed to reject the null hypothesis. So, how will we conclude that in step 6? What is the conclusion in the step 6 in this problem, in short? So, at 1% significance level, there is not enough evidence to support the consumer testing agency's belief that the true average lifespan of the LED bulbs is less than 15 hours. So, that is our step 6 in solving or testing the hypothesis using the significant approach or the p-value approach. So that concludes my part in the testing of hypothesis for a single sample. Thank you for listening. I hope you learn in my discussion, and I hope you understand as well the steps. So this is critical in learning for the next topics. So you have to understand first the fundamentals of this topic before you proceed to difficult problems. So again, thank you for listening, and I am Paul Jandrie. Thank you.